looking at bivariate data. Now, bivariate data sounds like a really fancy set of words, but let's actually break every single one of these parts down. So we've got bi, we've got variate, and we've got the word data. Now, data is a word you've seen before, and we need to be really careful. Data isn't anything fancy. It's literally just information we collect. It might be numerical numbers because we've measured something. We might be measuring the temperature on a thermometer every single day to get the weather. We might be counting the number of cars that go past Turner Road of a morning. Bi generally indicates 2, and that's exactly what we're talking about, the number 2. And our variate part is talking about variables. Now you hear about variables in science a little bit, but really what it means is we're measuring or looking at 2 different types of information. For example, height and weight. For example, how many Weet-Bix you eat of a morning and how much weight you can lift in the gym. And what we're really trying to identify is there a relationship between the 2 variables. Now, when I use this word relationship, it means does one affect the other? For example, does how high you stand or how tall you are affect how heavy you are? Or with the other example, if you eat 4 Weet-Bix instead of 6, can you lift less weight? Or vice versa. If you eat less, does that mean you can lift more? Okay, that's what I mean when I say relationship. And there's so many examples we can give you. Okay, I'm going to give you 3 examples. Number 1, number 2, number 3. So, for example, let's just look at the amount of rain versus the number of car accidents that happen. Versus, I'm going to use this. This is not a hashtag. This is a number sign. It indicates number. The number of car accidents that occur. So that could be 1. Let's go with the length of your hair versus your IQ, if you do an IQ test. And then let's go with the number of hours you spend gaming versus the, let's go with this hashtag again, number of hours spent sleeping, which is something pretty relevant to a lot of you. And it's really difficult to tell with these things if they have a relationship, if we can't view the data in any particular way. And the way that we view our data is we graph it, okay? And we're not quite drawing one straight line graph because we've got information that covers a whole length of stuff. So length of hair, you could be so many different lengths of hair, or 2. You could have huge numbers of IQ, you could sleep for not many hours, you could sleep for half an hour, you could have hundreds of car accidents, you could have very few millimeters of rain. So the way we try and figure out if there is a relationship is we have to view the data on a nice plot, okay? And we call them scatter plots. And these ones only have the 2 axes. They are only X and Y, okay? X across the bottom, Y, X, Y. And they're only in 1 quadrant, not like your Cartesian plane. And you're going to see different results, all right? Let's imagine the number of car accidents and the amount of rain. If this was how much rain we had, as the rain went across the x-axis and got more, you would assume that the number of accidents that happen go up. So if there's a little bit of rain, there'll only be a few accidents, versus if there's a lot of rain, there might be heaps of accidents. And you might see data that looks all over the place. Okay, this is why we call it a scatter plot. There are points everywhere. You can see a general trend, and that is as one gets bigger, the other gets bigger. And this is called a positive trend. On the flip side, we've got here length of hair versus IQ. Now, that doesn't seem particularly, intelligent to think about. If you've got short hair versus if you've got long hair, then that affects how intelligent you are. So really, we would expect to get points all over this graph. And if we've got points everywhere and we can't see a trend or a pattern, we can say there is no trend or no relationship between those two variables. If we keep going and we look at, say, the number of hours you spend gaming versus the number of hours spent sleeping, if you only spend a little tiny amount of time gaming, you would expect that you would be getting a fair amount of sleep. The flip side of that is, if you spend heaps of hours gaming, you're going to get very little sleep. And you're going to get points all over that graph as well. Just from my assumption, just from my educated guess, I would assume that that is the kind of pattern we would get. And that one, because it is sloping down, as opposed to, say, this one sloping up generally, that this one is a negative trend. I'm going to keep using trend, relationship, and pattern. So there are types of data and the way that we represent them to see if there is a relationship.